Eye disease classification using EfficientNetB0 project. Objective: develop a deep learning model that can classify eye diseases based on images. The model should accurately detect and classify images into 4 categories: cataract, glaucoma, normal, and diabetic retinopathy. The final deliverables include a trained model, evaluation metrics, and visualizations of model performance. Task 1. Dataset preparation. Dataset setup. 1. Locate the dataset in the specified directory, 2 data/, with subfolders for each disease category. 2. Ensure each class has its dedicated folder, named based on the disease it represents, e.g., cataract, glaucoma, normal, and diabetic retinopathy. Data loading and pre-processing. 1. Load images from each subfolder using OpenCV. 2. Resize all images to 224 by 224 pixels to match the input requirements for the EfficientNetB0 model. 3. Label the images based on the folder names. Split the dataset into training and testing sets, 67% training, 33% testing. Data transformation. 1. Hot encode the class labels for model compatibility. Task 2. Model development base model. Setup. 1. Use the EfficientNetB0 model with pre-trained weights from ImageNet. 2. Exclude the top layer since we will add custom classification layers. Custom model architecture. 1. Add a global average pooling layer after the base model. 2. Add a dense layer with 512 units and RealU activation. 3. Include a dropout layer, 50%, to prevent overfitting. 4. Add a final dense layer with 4 units, softmax activation for classification. Compile the model. 1. Freeze the layers of EfficientNetB0 to preserve pre-trained weights. 2. Use Atom Optimizer with a learning rate of 0.001. 3. Specify categorical cross-entropy as the loss function and accuracy as the evaluation metric. Task 3. Model training configure. Callbacks. 1. Set up early stopping to monitor validation loss and stop training if no improvement is seen after 5 epochs. 2. Add a learning rate reduction callback to have the learning rate when validation loss plateaus. 3. Use model checkpointing to save the model with the best validation accuracy as bestmodel.h5. Training execution. 1. Train the model for up to 20 epochs with a batch size of 32. 2. Use the training set for training and validate the model with the test set. Task 4. Model evaluation performance metrics. Calculation. 1. Make predictions on the test set. 2. Calculate accuracy, precision, recall, and F1 score for overall performance. 3. Generate a classification report showing precision, recall, and F1 score for each disease category. Confusion matrix. Analysis. 1. Calculate and display the confusion matrix to evaluate misclassifications. 2. Compute the accuracy per class from the confusion matrix. Plotting model performance. 1 plot. The training and validation accuracy and loss for each epoch to assess model learning patterns. Visualizing confusion matrix. 1. Display both a raw and normalized confusion matrix for easy interpretation of model performance per class. Task 5. Documentation and final deliverables code. Documentation. 1. Provide comments and descriptions in the code for each function and processing step. 2. Organize code into separate functions where possible for clarity. Final deliverables. 1. A trained and saved model, EfficientB0.h5. 2. Plots showing training and validation accuracy and loss. 3. Classification report and confusion matrix visualizations. 4. Documentation summarizing model performance and key insights for improvement. Notes: ensure to follow best practices for code organization and documentation to make the project maintainable and reproducible. Regularly update the project manager on progress, noting any challenges encountered and how they were resolved.